Alright, hey there folks and welcome back to chemistry. Our question for this week is why did the can crush when I moved it from the stove to the ice water? The can is a lot different than the balloon from last week. For one thing, it can't stretch or change its shape like the balloon. Unlike the balloon, the can is considered a rigid container, meaning it cannot expand or contract. When gases change temperature inside of a rigid container like this, instead of the volume changing, the internal pressure changes. Internal pressure is how hard the gas molecules push out against the walls of the container. If the pressure gets too high inside the container, you can have an explosion. On the other hand, if the pressure gets too low, you can have an implosion. In our experiment this week, we're going to see how the temperature affects the internal pressure for a container of air. Let's take a look. So in this experiment, we're going to use a test tube filled with air as our rigid container. You'll notice I'm hooking up a pressure sensor to that test tube. That's going to tell us how hard the air inside is pushing on the walls of the test tube. And it sends that information to that iPad that you see right behind it. Now I'm going to let that test tube just sit there in some room temperature water. Now one other thing that you'll notice about that iPad back there is that you'll see it's reading the pressure out in kPa, or kilopascals. That's just one of many units for pressure. The more kPa, the more pressure. Now I'm just going to let this test tube sit here for about 2 minutes. And we'll check the temperature there. It's about 25 degrees Celsius, which we remember from the last video. You can add 273 to get the Kelvin. We get 298 Kelvin. And we see our pressure is about 100.1 kPa. Now I'm going to go ahead and move our water over to this hot plate here. I'm going to let it heat up for about 2 minutes and check the temperature again. See, it's about 34 degrees Celsius, which is 307 Kelvin. So we add 273. And if we look on the pressure sensor, it's about 103.3 kPa for the pressure. We're going to let that sit on the hot plate another 5 minutes. And check the temperature again. This time it's gotten all the way up to 70 degrees. I know it's a little lower on the thermometer there, but that's because the thermometer dropped very quickly after I took it out, but it was 70 when it was in the water. That converts to 343 Kelvin. And the pressure sensor, you'll notice, is drifting up and down a little bit, but on average, it's about 115.0 kPa. Finally, we're going to let it sit on the hot plate just 1 more minute. And the temperature, I didn't show it on camera, but I did check it, was 80 degrees Celsius, which is 353 Kelvin. And the pressure, as you can see up there, is 118.0. One final thing I want to show you. I'm going to remove the stopper here. You hear that? That's all that pressure that was building up, finally releasing because we've opened the container. With that, in the information linked in the summary table, you should have enough information to figure out why the can crushed. Remember that over this 5-week unit, we're developing the puzzle pieces to explain how a weather balloon works. I'll show you more about the weather balloon in later videos. Also, don't forget about our distance learning cycle. Watch the video, then complete the summary table or attend one of my daily office hours, 2 p.m. on weekdays. Both of these are available on Google Classroom. I hope you're doing well, and I'll see you next week.